When we look at firm-level decision-making, we're going to classify firms into one of the following four market structures. And in the previous chapter, we looked at decision-making in perfect competition. Now we're going to look at decision-making in a monopoly market structure. When we classify firms in terms of market structure, we're going to look at how many firms are in the industry. Is there only one producer? Are there a relatively small number of producers, or are there many producers? Similarly, we're going to look at whether the product that's being produced is standardized, meaning that it's not differentiated. Farmer Jones's corn is identical to Farmer Smith's corn. Or whether the product is differentiated. For example, in the automobile industry, even in a compact car class, the Honda Civic and the Toyota Corolla may be in the same class of cars, but there are unique product characteristics that differentiate these products. In a monopoly market structure, we have only one firm in the industry, and the product is not being produced by any other suppliers. So there are no close substitutes. In an oligopoly market structure, typically there's a small number of firms in the industry. The product can either be differentiated or it can be non-differentiated. In perfect competition, there are many firms in the industry, and the product is standardized or not differentiated. Monopolistic competition, there's many firms in the industry, but it's a differentiated product. In a monopoly market structure, you want to be the only seller of railroad services. You want to monopolize that railroad industry. So in a monopoly, there is only one firm in the industry producing a product that doesn't have close substitutes. So the one firm in that industry is known as the monopolist or the monopoly firm. And in this market structure, if the firm was allowed to pick any price point they wanted, they would clearly have the ability to raise prices above what would exist if there were more competition in the market. Show a graphical representation of this. If this were a perfectly competitive market, this would be the market demand curve, this would be the market supply curve. The interaction of buyers and sellers would determine a competitive market price of PC, and the corresponding equilibrium output would be QC. In a monopoly market structure, we're going to show that the monopolist is going to have an incentive to raise the price above the competitive price. We're calling this the monopoly price. And because the monopolist faces the entire industry demand curve, at this price, the monopolist isn't going to be able to sell as much output. So compared to perfect competition, the monopoly output is going to be less, and the monopoly price is going to be higher. Subsequent slides, we'll try to explain how monopolies arise and how they develop these barriers to entering an industry so that there is only one firm that's able to produce a product that doesn't have close substitutes. In the subsequent slides, we'll look at some of the reasons why industries are able to become monopolies where there's only one firm in the industry. What accounts for these barriers to entering the industry? And we can look at firms that control natural resources or inputs and therefore are the only producers. We can look at firms that have increasing returns to scale and decreasing average total cost structures. We can look at firms that have technological superiority and which restricts entry into a particular area. We can look at government barriers to entry, like the patent and copyright laws that inventors and composers are entitled to. De Beers is the textbook example of a firm, an international firm, that at one time controlled over 90% of the world's uncut gem quality diamonds. So diamonds are forever, and while De Beers was owned mines in South Africa and Australia and was able to enter into supply agreements with other mines in Russia and other places, they were able to restrict supply and therefore had monopoly power in that diamond market. It's an interesting case study to look at. Well, was De Beers able to maintain these barriers to entry? And what you'll see is that it became more difficult for them to control the supply of diamonds, and there was a synthetic substitute that affected the demand for gem quality stones. So from a case study perspective, De Beers is quite interesting. Natural monopolies are said to exist when a firm has increasing returns to scale and production. And as we explained earlier, increasing returns to scale means that if you double the amount of your inputs, you're going to more than double your output. So what that means is as you increase the size and scale of your operation, you're going to decrease the average cost of providing that product. So things like a dam project, it only makes sense to have one company that's producing that dam, or even utility companies that put in electrical lines into your neighborhood. If they hook more people up to those lines, it's going to decrease the average cost of providing that service. So to some extent, they're considered natural monopolies because it's only natural to have one firm in the industry if it can lower their cost of production. And this shows it graphically. As this firm expands their output, guess what? Average total cost is decreasing. So if there's one firm in the industry, they're able to satisfy demand at a price that's much lower, at least in terms of break-even, than it would be if there were more than one firm in the industry. So if you only had two firms in the industry, each sharing the market, their average total cost of production would be much higher than if there were only one firm in the industry. So for that reason, industries with increasing returns to scale are sometimes referred to as natural monopolies. If a firm maintains technological advantage over its potential competitors, what it can effectively do is either reduce or eliminate other firms entering that industry. So if you look at the two major aircraft carriers, you've got Boeing and Airbus, with the technological superiority to make those large fuel-efficient airplanes. So it's not a monopoly because there are more than one firm in the industry, but It's this technological superiority that restricts entry of other firms. Externalities are an interesting phenomenon since the popularity of social media. Facebook, for example, if you increase the number of users of the Facebook platform, that's going to increase the value of the platform to other potential users. So as the size of the company increases in terms of users, so too does the demand for that particular service. And it makes it much more difficult for a startup social media company to compete when you have embedded companies that have huge user bases, and you have a situation where the value to a new customer depends on the number of friends and other users on that platform. So what this effectively does is it gives a real position of strength to companies that have a large scale of operations. The government for prescription drugs, for example, if a pharmaceutical company develops a new drug, they have roughly 8 years to sell that drug with no competition. So the patent laws effectively create a monopoly for a company over the period of time that the patent exists. Similarly, if you write a play or a book, copyright law protects you from other competitors using the work that you develop. In the United States, when a prescription drug is under patent, prices tend to be the highest in the world. So you can look at Nasonex. The price in the United States is $108. Other major industrialized countries, $39 in Switzerland, $29 in Canada, $12 in the United Kingdom. And if we looked at developing countries like India or Mexico, drug prices could be significantly lower than this. So we'll address this later, but for now, keep this graph in mind and ask yourself, well, why are drug prices so much higher for prescription drugs in the U.S. than other parts of the world? We can look at this from the perspective of an individual producer. In a market structure characterized by perfect competition, individual producers don't have any control over the market price. The price is determined by the interaction of buyers and sellers in the overall market. And if you're a corn producer in the Midwest, you don't have any control over the price of corn. If you're a domestic oil producer in the mid-continent, you don't have any control over oil prices. It's not a decision variable for you. Whatever the overall international market determines the price to be, that's what you're able to sell your production for. You don't have any pricing power. Compare that to a monopolist. The one firm that's in a monopoly industry, they face the entire market demand curve for their product. They're the only producer. And if they can estimate this demand relationship, they're going to choose a price point because they do have pricing power. Choose a price point that's going to maximize their profit. So that's a choice variable or decision variable to that particular firm. And when we set this up as a decision problem for a monopolist, in a simple model, they're trying to maximize profit, which is the difference between total revenue minus total cost. We assume that they know their cost structure with certainty, so they know what their cost relationships are, and we're assuming that they can estimate the demand relationship in their market so that they can estimate what the demand curve is. And then when we look at this as a decision problem, we can show that our monopolist is going to produce at an output level where their marginal revenue is going to just equal marginal cost. And marginal revenue is the change in total revenue divided by the change in output. And what we'll show is when a monopoly firm is considering a price point, they know that if they lower the price, they're going to be able to sell more output because their demand curve is downward sloping, but they're not selling each unit of output for as high a price. So any price change incorporates both this quantity effect. If you have a price cut, how much additional quantity is going to be sold? And it's going to have a price effect because when you lower price, you know that the price you get per unit is going to be lower. So when firms are looking at what their revenue is going to be, they have to take these two effects into account. We have a hypothetical example giving us the demand relationship for diamonds. So if the price is $1,000 per carat, the quantity demanded is going to be 0. If the price is $950 per carat, the quantity is going to be 1. If it's $900, the quantity is going to be 2. So what we have is our demand relationship that we can estimate in the diamond market. It shows the relationship between price and the quantity demanded. Okay, and given this demand relationship, we can calculate total revenue. If we charge $1,000 per carat and don't sell any, our total revenue is 0. If we charge $950 and sell 1, our total revenue is $950. If we charge $900, sell 2 units of output, our total revenue is $1,800. If we charge $850, sell 3 units of output, our total revenue is going to be $2,550. So if we know our demand relationship, we can calculate what total revenue is. Then we can calculate marginal revenue. Marginal revenue is the change in total revenue divided by the change in output. So here, when we go from 0 to 1 unit of output, total revenue goes from 0 to $950. So we have total revenue increases by $950. That's the change in total revenue. The change in output goes from 0 to 1, so the change in output is equal to 1. So our marginal revenue, when our output is between 0 and 1, is $950. Okay, now in an output range, if our output goes from 1 to 2, total revenue goes from $950 to $1,800. So that's the change in total revenue is $850. The change in output is 1. So $850 divided by 1 gives us a marginal revenue of $850. And we can do that throughout here. When we in the output range between 9 and 10, total revenue goes from $4,950 to $5,000. So the change in total revenue, it increases by 50. The change in output goes from 9 to 10. The change is 1. So our marginal revenue, if we lower our price from $550 to $500 per carat, the marginal revenue that we're going to get is 50. So you can see that if we know our demand curve, we can calculate total revenue and also calculate marginal revenue. Now on the next slide, what we're going to do is we're going to plot our demand curve and we're going to plot our marginal revenue curve and see what we get given this information. Here we have our demand curve at lower prices. You know, the price is 500, 450, and so on. So this gives us the rest of our demand curve. In the same way, we can calculate marginal revenue. And it's interesting, when we lower our price from 500 to 450, we actually sell more diamonds, but our total revenue actually starts to go down, which means that our marginal revenue is going to be negative. When we lower output, or lower the price in order to sell more output, our total revenue actually goes down. So our marginal revenue then is going to be negative. So on this slide, we're graphing our demand curve. Okay, from the previous table, we can graph our demand curve. Each point on this graph is we're graphing quantity on the horizontal axis, and we're graphing price on the vertical axis. So when price is equal to 1,000, the quantity demanded is equal to 0. And when the price was 550, the quantity demanded was equal to 9. And when the price is equal to 0, the quantity demanded is 20. So we can plot those points from the previous table and get our demand curve. Then we can plot marginal revenue. And typically when you plot marginal revenue, you pick the midpoint to plot it. So what you can show is that your marginal revenue curve, if you have a linear demand curve, has the same intercept on the y-axis. You're plotting quantity and marginal revenue, but it has a slope that's twice as steeply sloped. So here, for example, if we plot our marginal revenue, we can see that below 500, our marginal revenue was actually negative. So if you plotted these points, we would get and fit a curve through it, we would get our marginal revenue curve that's linear below the demand curve and twice as steeply sloped. And we can show through algebra why that would be the case for any linear demand curve. But at this point, you know, what we're showing is the demand curve and marginal revenue on the same first graph. And the second graph shows that what happens to total revenue as your sales increase. So what this shows is that our total revenue is going to be greatest when we're selling 10 units of output. If we don't sell any units of output, if we choose a price that's so high that the quantity demanded is 0, then our total revenue is going to be 0. Then as we decrease price, our revenues go up until we're selling. Then beyond that, we're reducing the market price in order to sell more. Revenue starts to go down. So once we're charging a price of 500, if we lower that price, our sales still go up, but our sales don't go up enough to offset the price effect of the lower price. Okay, now that we've seen what marginal revenue looks like, marginal revenue tends to decrease as you're selling additional output because of that price effect. So now our decision rule is what you do is compare, again, you compare marginal revenue to marginal cost at each output level. And if you're at an output level where marginal revenue is greater than marginal cost, you're going to want to expand output. If you're at an output level where marginal revenue is less than marginal cost, you've gone too far and you can reduce output in order to increase your profits. So our decision rule then is to find the level of output, I'll call it Q star, where marginal revenue equals marginal cost. Then once you find this level of output, you use your demand curve in order to choose the price that's going to maximize profit, which is the price from your demand curve. And a third step might be to actually calculate what your profit is going to be at this price and at this output level. So you could calculate what your profit is going to be. And if we wanted to get a graphical solution to this decision problem, graphical solution means that, well, okay, we're given this graph where we know what our demand curve looks like. We've plotted our demand curve and we've plotted our marginal revenue curve. And you can see if we have a linear demand curve, marginal revenue is going to have the same intercept on the vertical axis, and it's going to be twice as steeply sloped. So demand, when price is equal to 0, the quantity demanded would be 20 units. And here, if marginal revenue is equal to 0, we're going to be at 10 units of output. So it has the same intercept on the vertical axis, and it's twice as steeply sloped. Okay, so now how do we solve this decision problem? We're going to choose a level of output, Q star, where marginal revenue just equals marginal cost. That's the first step in our cookbook approach here. So here, okay, well, what does that mean? It means here we've assumed that our marginal cost is constant. It's always 200. So what does that mean? It means that, well, okay, if marginal cost is 200, marginal cost equals marginal revenue at point A. So the output level that's going to maximize profit for our monopolist, Q star, is going to be 8 units of output. The most common mistake students make is they say, well, okay, we're going to just go over here and charge a price of 200. Well, the monopolist says, well, if we want to sell 8 units of output, we can go up to our demand curve. Going to go up to our demand curve, and what we're going to charge is $600. So at this price, the demand curve tells you the quantity demanded is going to be 8. So our decision process is, while we find an output where marginal revenue equals marginal cost, that's 8, and then we go up to our demand curve and choose a price, and in this case, the price for the monopolist to charge is going to be 600. So we charge 600, sell 8 units of output. We're going to maximize profit as a monopolist. And how do we know that? Well, here, for simplicity, they said that average total cost is constant, and it's equal to 200. Okay, so here, how much are you making per unit? The price you're charging is $600. Price is $600. Your average cost is $200, so you're making $400 on each unit that you sell, and you're selling 8 units of output. So your profit is going to be the profit per unit times the number of units that you sell. So in this case, it would be 400 profit on each unit times the 8 units of output that you sell. So what that would be, $3,200. So our monopoly solution is going to be a price of $600 and a quantity of 8 units. If this were a perfectly competitive market, price would be determined by the interaction of supply and demand. So here is our industry demand curve, D, and if this were a firm acting as a perfectly competitive firm, the supply curve would be the marginal cost curve for that producer. So the supply curve would actually be this marginal cost curve. So this would be the quantity where supply equaled demand. This would be the equilibrium price where supply equaled demand. So if this were a perfectly competitive firm, the price would only be $200. The output would be $16. So what you can see is the monopoly output is much less than the competitive output, and the monopoly price is much higher than the competitive price. We can show this monopoly profit again. Okay, the first step, the firm finds a level of output where marginal revenue equals marginal cost. So this is our marginal cost curve. It intersects marginal revenue here. So point A gives us the point at which marginal revenue equals marginal cost. So this QM is the output level the monopolist is going to choose. Then you go up to your demand curve and choose the monopoly price. And at this monopoly price, you can see the average, at this output level, average total cost is here. The price that you're charging is here. So if you take PM minus average total cost at an output level of QM, you get this vertical distance that's your profit per unit. So this is how much the monopolist is making on 1 unit of sales. This is the profit per unit. Multiply that by the number of units that you sell, gives you total profit. So we multiply the profit per unit times the number of units we're selling, and we get this blue shaded area, which is the monopoly profit. And as long as the firm can maintain these barriers to entry, they're likely to keep their market share, and there's no reason to think that they can't maintain positive economic profits in the long run if other firms aren't able to enter this industry. From a theoretical perspective, it's interesting to note that a monopolist does not have a supply curve. A supply curve is the unique relationship between price and the quantity supplied. So it means, well, you tell me what the price is, say $600 per carat, and you have a unique quantity supplied. And in a monopoly situation, what the monopolist does is it actually looks at the overall demand characteristics in the market, and it sets a price and output that's going to maximize profit given its cost structure and those demand characteristics. So if there are changes in the demand characteristics, it's possible for the monopolist to provide different levels of output at exactly the same price. So we could show that in examples where the demand curve shifted, and the monopolist would maximize profit by charging exactly the same price, but possibly producing additional output. So technically, there is no supply curve for monopolists because the monopolist may choose to supply different quantities based on different demand characteristics. So there is no price output combination that could be viewed as a supply curve. As we stated earlier, in an environment characterized by monopoly, markets do not allocate resources efficiently, and this can be confirmed by comparing the total surplus of perfect competition versus a monopoly market structure. So in the first graph, the area under the demand curve above the price line is consumer surplus. Producer surplus would be the area above the supply curve to the price line, but in this case there is no producer surplus. So the blue shaded area is total surplus. Then we move to the second diagram, and we see that consumer surplus is the area under the demand curve to the price line, which would be this dark shaded area. Producer surplus is the area above the supply curve, or above the marginal cost curve, to the output level that's being consumed. So this would be our producer surplus, or profit. And what we can see when we compare these shaded areas is this red shaded area that's labeled dead weight loss is our loss in total surplus resulting from our monopoly market structure. So you can see total surplus is greater in perfect competition than it is in the monopoly situation. So we can verify that in a monopoly market structure, if we rely on markets to determine prices and quantities, the price is going to be too high and the quantity is going to be too low to be economically efficient. So from society's perspective, the monopoly price is too high, the monopoly quantity is too low, and it results in this dead weight loss of total surplus. How does the government respond to that? And typically, the antitrust legislation in the United States, going back to the later 1800s with the Sherman Antitrust Act and subsequently the Clayton Antitrust Act, make it illegal for companies to try to monopolize certain industries. And if you go back to that time period, you had the John Rockefeller case where the Justice Department brought suit against Standard Oil for trying to monopolize the oil industry in the United States. And today, when you have a merger of companies that are large companies, the Justice Department scrutinizes those potential mergers to see how it affects the market structure in that particular industry. Does it give too much power in terms of market size to the merged company? And does it anticipate that loss in market competition is going to significantly impact consumers in the form of higher prices and other factors? And if it does, the Justice Department is going to attempt to have those companies modify the terms of the merger, or not question or contest the merger in court based on antitrust violations. So in general, what the government does is to try to promote effective competition in most industries. In the case of natural monopolies, where firms have this declining average cost structure, where one firm can have lower costs of production than if there were more than one firm in the industry, the government typically allows those utility companies to be monopolies, but what it does is it regulates the prices that they can charge so that the firms typically are allowed to earn normal economic profits, but not above normal profits. So from a public policy standpoint, government typically regulates the price that utility companies can charge in order to ensure that their firms are earning a normal profit but not above normal profits. Another example is the U.S. Postal Service, where it's actually the government that runs the Postal Service. This slide shows in graph A the solution for an unregulated natural monopolist. Then in graph B, we see what the government does is it puts in a regulatory price where price equals average total cost. And we know that if price equals average total cost, that this firm is earning zero economic profit, or you could argue that it's a normal profit. And in this example, you'll see that the regulated price is much lower than the price that the monopolist would have an incentive to charge if they were allowed to charge the price point that maximized their profits. And we can also see that the amount of consumer surplus generated through this type of regulation increases substantially. This next section, we can look at how firms can engage in what's known as price discrimination, which third-degree price discrimination means that different groups of consumers are charged a different price for exactly the same product. And we'll look at why firms do this and be able to show that anytime a firm can effectively segment their market across different groups of consumers with different price sensitivities and different price elasticities of demand, the firms can always increase their profits by engaging in this type of price discrimination. They'll charge a lower price in the market where consumers are more price sensitive, a higher price in markets where consumers are less price sensitive.
Yeah.
So price discrimination involves a firm charging a different price in different market segments for the same product. In third-degree price discrimination, the firm estimates the demand relationship for each market segment, and then in that market segment chooses an output where marginal revenue equals marginal cost, goes up to the demand curve and chooses the appropriate price. And the firm would do that in each of the market segments, and the end result would be charging a higher price in the market where consumers are less price sensitive. Examples of price discrimination are when senior citizens are given lower prices for movie tickets and so on, or leisure travelers are given lower prices for airline tickets. Revenue management strategies in airlines are particularly interesting from a perspective of price discrimination, and we'll address those. In this example, we have two types of travelers: business travelers that are not very price sensitive with a high willingness to pay, student travelers with a that are highly price sensitive with a lower willingness to pay. If we charged the price of $150, we'd be able to sell a total of 4,000 tickets, but our profit would only be $25 or $75 per ticket, and our total profit would be this smaller hatched area. If we chose the higher price, $550, we would only be able to sell 2,000 tickets to business travelers. The profit to business travelers would be this hatched area, and we would be missing out on any profits from our student traveler segment. So in our price discrimination, if we can segment the markets, we could charge a price of $550 to the general business travelers. We could charge a price of $150 to students, and in doing that, we would be able to increase our profits by the amount of profit, $75 per ticket for an additional 2,000 tickets. So you can see, by segmenting the market, charging a higher price to consumers with a higher willingness to pay, lower price to consumers that are more price sensitive, firms, if they're able to segment the market in some way without having tickets resold between the market segments and other types of cannibalization, firms can increase their profits by engaging. You can see, if we can segment our market into 3 segments rather than 2 segments, the firm, by charging 3 different prices, high price, a medium price, and a low price, our representative firm would be able to expand their profitability. So in general, if firms can micro-segment markets in ways to charge higher prices to consumers that are less price sensitive, they'll be able to increase their profits. And in modern yield and revenue management strategies, this market segmentation can occur not only in the fashion that we've just noticed it, but it can also be employed dynamically over time. So if you have a hotel, for example, that has differing demand patterns during high season versus low season, or restaurants have different demand patterns based on weekend and versus lunch situations, or golf courses that prime times are in the morning on Saturdays and Sundays. They can segment markets by charging higher prices during those peak periods, lower prices off-peak, and result in a micro market segmentation that improves profitability tremendously. Perfect price discrimination involves involves extracting. Perfect price discrimination is when the firm is able to extract all of the willingness to pay from a representative consumer. This means that they essentially capture all of the consumer surplus. In order to extract all the consumer surplus from a representative consumer, you can think of an example of theme parks, where they can charge a price per ride, $2, $4, $6, $8, $10, $12 a ride, and for this is the demand curve for our representative consumer. And if they charge $12 a ride, consumers choose to go on no rides. If they charge $6 a ride, consumers are going to go on, let's say, 4 rides. If they charge $2 a ride, consumers are going to go on, say, 8 rides. And if the price is $0 per ride, they're going to go on 10 rides. So if our theme park charges per ride, if they charge $6 and they go on 4 rides, total revenue is just the price per ride times the quantity demanded. So if they charge $6, consumers go on 4 rides, that's only $24 in total revenue. Similarly, they could charge $4, consumers may go on 7 rides. Again, $4 times $7 is $28 in revenue. If they charge $10 a ride and consumers go on 3 rides, okay, they're charging $10, consumers go on 3 rides, that's $30 in total revenue. So regardless of what price per ride, their revenue is going to be maximized somewhere in the vicinity of $30. Now let's assume that they're able to calculate what the willingness to pay for this consumer is. The willingness to pay would be the total area under the demand curve. And the total area under this demand curve is, it's this right triangle, so it's 1/2 the base times the height of the triangle. So it's 1/2 10 times 12, which is equal to 120 divided by 2, or $60. So if this theme park charges a price per ride of 0, you can go on as many rides as you want for free, this consumer would be willing to pay $60 for a daily pass that allowed them to do that. So if you compare the per ride revenue maximum of $30, if the theme park prices its daily admission fee at $60, what's going to happen is this consumer is going to go on 10 rides. They're going to be willing to pay $60, and what this theme park has done is extracted the total willingness to pay from this consumer. So what they're actually paying is the maximum that they're willing to pay, which would mean that they've extracted all of the consumer surplus. And that's why with the theme parks, rarely do you go to a theme park now where you pay per ride, because they're able to devise a pricing strategy on a daily basis that extracts all of the consumer's willingness to pay and all of their consumer surplus.